Hello. Welcome to well, this is odd. I can't think of when I've streamed myself before. Good evening. This is Shipwrecks and I am Velmax. Ghost is not feeling so great tonight, and there's a good bit of that going around, honestly. I'm just gonna adjust the sound. I wasn't feeling that great today either. I took a half day from work, but now I'm feeling a bit better, and here's some While True Learn with you, which, if you aren't aware of it, is a kind of, I think learn to program is maybe kind of a strong that's interesting. I'm not seeing myself on Restream. Let's just refresh that. Kind of maybe teaching computational thinking is maybe more the way to think of it. I'm a fair just kind of restarted it the other day, and I'm a fair bit through my old save. So I'll just kind of go back and redo some of these early sessions. So the conceit here is we're a programmer. Oh, there's bugs. So many bugs. Can't figure them out. Need some more coffee to figure them out. And while we're making that coffee, our cat gets on our terminal and solves our problem. But we can't communicate with our cat. So we're going to need to build a cat speech recognition device in order to do that. And so it's kind of maybe educational game is the kind of way to think of this. And as you go through, it kind of gives you these little like nodes that you play with that are kind of simulating what's going on with an algorithm or something. And there's like fake Stack Overflow, and you get to learn about all different things like I'm not a machine learning person yet, but maybe I will be after I'm done. But the goal is to kind of I had gotten this one to work on my other save. Well, anyway, I'll have to figure it out again. Oh, I got gold. It doesn't really work that well. But that's alright. We'll take it. Oh boy. Anyway. So you have all these little challenges, and then you do these like coding things and learn about training and all that good stuff. Let's see how this goes. Yeah. I mean, I don't know. I don't know what to say so much about this one. I guess we only need 10 to go there. Why don't we do that? And you know, you get to do like all of this optimization. It's kind of fun. You have like a little timer, And you've got like a maximum number of nodes that you can use to get a gold, a bronze, and a silver. You kind of get, you know, monies for doing things, and then you can use that money to buy stuff. Like I got some plants. You can buy new nodes to do new machine learning things. And you can also buy computer upgrades that allow you to process things faster. And
I heard you could buy costumes for the cat.
Ghost is saying that they heard you can buy costumes for the cat. Yes. Whoops. Why did this open? Okay. We can get a little Viking helmet for the cat. Aw. That's okay. That was a lot of money. That was like 3,000 cat euros. These are all our jobs. Ooh, we can start a new startup. Oh. Let's see. So we've got decision trees. Oh, random forest. Oh, I didn't redo that. So, yeah. I think I'm gonna have to do some replaying here. Let's see, toy manufacturing. How does this go? This one took me a long time the other night. All right. So we have to have these, and we need to train them. Hey, Rain. Cat costumes the most important part of any game? Yes. All right, so we can have 4 nodes. I think we'll want to train these ones next. I guess maybe I should have just started a new game, but oh well. So there's more squares, so I think we probably want to send the squares down here. Oh, I didn't do training. Whoops. I don't know. I kind of like it. Okay, our nodes are trained, so we want circles to go up here. We want squares to go down here. And then let's send triangles here and see what happens. Oh. I forgot to send circles back up there. So let's test this again. All right, so our circles are filling up first. And then we need more to go down to where our squares are. So let's send these here, and we'll send those circles there, and then we'll send our triangles down here too. And let's see what happens. Let's see if we can beat the clock. Oh, those squares fill up so fast. Come on. Yes, we got a gold. And not a small part of that is my equipment getting upgraded. But that's okay. So there's a fun bit where you can do where you get to show like supervised learning, so you can drive the little car that you're machine learning. Let's see. Oops. That's a tough one. So you're training, you know, it's all very high level, but, you know, you're training the car how to swerve and such. Let's do that again. I think I can do better. I don't know. One day I'll get that pass. But for now, it's fine, I guess. All right, and so now the car's gonna drive itself. Oh, that's bad. Oh, wow. Dang. All right, I'm gonna have to retrain that. Oh, hey, Isaac. I haven't seen you in a while. Average software expert needs money, not sleep. Ugh. I guess, does that mean I'm below average? Because I definitely need lots and lots of sleep. Okay. So we detect a car and we swerve. Detect and swerve. Detect and swerve. Oh, it wasn't accelerating. That wasn't great. Guess I could do this all night. Alright, let's see how it does this time. Oh, that's still no good. Why is it doing that? Oh, that's not great. I don't know. Oops, sorry to get an extreme close-up of my forehead there. Let me make sure. See how this is doing.
Is your kitty in the car?
No.
I see something in the car.
Oh, is it?
Over on the right. There was.
Oh yeah. I guess the kitty's driving.
Well, there's your problem.
Okay. Do, do, do. Do, do, do. Do, 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 do. Do, 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 do. Alright. Let's see if this I don't know why it's It's doing that. There's something wrong with the input it's picking up. I wonder if it's because the mouse is being funny. Let me take the mouse out and see if I get the same issue. This also demonstrates why self-driving cars are likely a long way away.
And why cat-driven cars are even farther.
3 of 5. Something. I'm missing something. It's supposed to train and evolve. Alright. Alright, I'm gonna hit save. Anyway, I don't know. We really don't need that one anymore. Sales prediction. Isaac Harvey has said, life has been a bit much. Wow. Okay, that one we did. It's a load balancer. That one I did. Alright, let's predict some sales. And so basically it gives you like either shapes and or colors, at least from what I've done so far. And you just, you know, it's basically doing a lot of conditionals. Oh, this one looks complicated. I don't know. Rain, maybe it's giving you flashbacks to work. Let's see. I have 17 seconds to do this. Let's see. So that has 21, and that has 29. I think we probably want to split this up first. And then let's make our decisions. Okay, so we split this, and then we want any color can go up here. We want, let's say, red to go down here, blue here. And we want green to go here and red to go here. And let's see what happens. Woohoo! Oh, look at it go. Nice. Okay. You see, it's true. I did learn. I did learn. Now, we're missing all the story. The stories are kind of funny. Uh-oh, what did I do? I'm gonna assume this was here. Oh, wow, look at that go. Dang. Alright, so we've got 23 seconds. Gonna have more of these. So let's add another balancer node here. And then we want, let's do this again. And so we'll add this here. Whee! Oh, hey, it worked. Nice. Large parallel calculations. Deep news, the darkest years of machine learning. In 1969, nice, Seymour Papert and Marvin Lee Minsky wrote a book called Perceptrons. In this book, they spoke about math constraints of the first perceptrons, the exclusive OR problem. This book has shifted the scientific interest and funds distribution from the U.S. government organizations, slowing down the progression of machine learning for almost 30 years. Wow. The expanded version of the book was released in 1987, containing chapters that disprove the statements from the critical remarks made since 1969. Let's see. So we want red, 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 red. Whee! Okay. What's our next? Secret information. Let's see if we can find the brief for this. Secret information. Good day to you. We are a secret military organization. Our code name is Protoss. Everything you are going to read further is classified. Our analysts are sending operatives to various war zones. An escalation of conflict with the enemy has recently occurred. We are in need of a self-learning algorithm capable of sending dedicated units to respective parts of the battlefield. Yeah, so the game doesn't really shy away from, you know, the idea that a lot of machine learning is just going towards, you know, let's say, covert or maybe not the most utopian of practices. All right, so we're going to use a balance. We're going to split this, and then you can just send stuff here. We want red or blue to come here. And we want green and blue to come here. I think we're going to duplicate that. Now let's see what happens. Whee! Oh, I just love watching that load balancer work. Alright, well, that didn't work. So let's send any this way. Maybe we can get some more going here. Let's do that to this node too. Whee! So fun. Oh, hey, it worked. And so the kind of interesting thing is that, like, a lot of it seems like as in life, it doesn't have to be, you know, perfect. It's just gotta kind of work. Let's see, Cyber Initiative. Greetings, our company Cyber Initiative is into manufacturing androids. Our production lines are fully robotized. The only function which is still performed by human workers is logistics. We're shipping our androids to the government, military companies, etc. We would like to automate this process with an algorithm that will distribute androids depending on their characteristics. Glory to the robots. Oh boy, what did I do with this? Oh, this is, this is putting the spaghetti in spaghetti code. Let's see what happens. Oh, it's so slow. It's so slow. Oh my god, this must be version 2.0. And we ran out. Does this one work? No. About version 3. Does version 3 work? No. How did I pass this one? All right. So let's think about what we need to do. I think we definitely want to start with a balancer. And I'm just gonna say, since we're gonna need so many nodes, that we're probably gonna need 2 balancers. So we can kind of do stuff in parallel. This is going to be hard because we only want to send red ones here. Alright, what I think we want to do is we want to have red and blue. Alright, let's just see what happens when I do this. Alright. So that one's not getting enough. Alright, let's send these red ones down here. Add another one of these, and we'll send any up here, and reds here. See if the accuracy is low. I just love watching the little cubes go around. Okay, we want red, green, and then red, blue. Let's just see what happens here. Whee! Whee! Oh, that accuracy is so low. Oh. But we're almost there. Okay, let's see how this goes. All right, so see how that works. So I need more reds. Is that enough reds to get us there? No. We've got 40 reds, so we need all the reds. To come here. Mm-hmm. No. Don't know what I'm doing now. How's everyone else doing tonight? Okay, that's good. And let's just have this go here. Let's try that. That might do it. All right. So we want this to go here, and then half here, and half here. Let's try that. Whee! Yeah! All right, that was a good one. Dictatorship. That sounds not great. Sounds not great. Let's see what the brief was for that. Greetings, this is the only state internet provider of a small country. We have a rather suboptimal code to track our people's activities. Unfortunately, we cannot allow you to change the actual code, but we have several new servers purchased on a garage sale. Parallel the calculations. This will help our tyranny prosper. But look at all those cubes flow. Look at the cubes flow. Look at them go. Yeah. And there's also things called startups that you can do, which kind of make money. Ooh, private message. Letter from a friend. Hey, what's up, buddy? How are you? Listen, I know I wasn't paying you for quite a long time, and I'm very grateful you weren't demanding for a paycheck for so long. But to be in debt, even to a friend, is not cool at all, right? Therefore, take this money you've honestly earned. Thank you, friend. You've really helped me out. Yeah, and how about we go to that concert next week? Okay. Well, that was nice. There's nothing else really new that we can buy. Let's look at our tree. Prediction of elections. That sounds above board. Good morning. We're contacting you on behalf of Yahoo's Corp. The president of our partner venture has been dismissed last month, and the board of directors is in the process of electing a new one. We need to be able to predict who will win the election, so we could make a decision about the future of our partnership with said venture. Make it happen, and you will get a handsome reward. Kakita Shisumo says, "Are we the baddies?" Yeah, I think we are. Oh, but look at the little cubes go.
Wait, so you can't, like, reject these horrible...
I mean, I guess the only, if you Ghost is asking in the background, you can't reject these jobs, and I said, I think the only way to win is to not play at all. I just love watching the little cubes go. Oh, isn't that brilliant? A tracking system. Ooh, legitimate ruler at cat.meow says, dissident friendly tracking system. Flourish and prosper, respected programmer. We represent our glorious democratic leader, Admiral General President. Blah, blah. In his infinite wisdom, he orders you to create a system that would process the recordings of kitchen talks of our beloved government critics, so they would be sent to our country's famous recreational camps. We'll pay you a share from each individual who joins our national healthcare program, too. Ooh. One last detail. You must only use technologies developed in our countries as we despise your Western technologies and wish you all slow and painful death. Have a nice day. Okay. Well, that one's done. Heritage protection. Oh, that one sounds nasty, too. Oh, boy. Good morning. We have dozens of scientific equipment placed in protected areas for the sake of looking after the subjects of objects of national heritage. We're parsing the info from our equipment on a daily basis and need to sort it depending on the color of the report. Can you make a program that will help us? I mean, this one seems a bit too easy. Sales prediction number 2. Oops. Hi, I have a clothing store and want to know how much money I might earn during the holiday sales. Help me. Okay, that one doesn't sound so bad. Let's see what happens. Okay. We did it, Reddit. Okay. Alright. Game is on. Hey, it's Jeff. I own a small online bookstore. I need your help in choosing a logistics company depending on a client's region and type of book ordered. I would love to automate the process with the help of a special program. I offer you a share of sales made with the help of your system. Please note that the entire data needs to be processed. Okay. Oh, that's a lot. How do these work? Okay. Learning time. Random forest. This node compares color and shape of an element with each of the sockets and selects the one with the least amount of errors. If there are several matching sockets, a random one is selected. In the real world, a random forest is a composition ensemble of several decision trees. In real-life tasks, the number of trees can reach up to several thousands. Each tree can distinguish several classes, but they were trained on different parameters and classify objects based on different characteristics. When a prediction is required, a forest asks for the class from all trees and chooses the winner by voting, picking the most popular answer. Let's see, in an isolation forest. If the element satisfies both conditions simultaneously, it goes to the upper socket, otherwise it goes to the bottom. Isolation forest is one of the simple algorithms for detecting anomalies. Same as decision tree and random forest, isolation forest, which sounds like a great horror game, distributes incoming elements into the leaves of the trees. The fewer questions it takes to separate an element from the rest, the more anomalous it is considered to be. Anomalous materials. Alright. So I think we're going to want green squares to go here. So the interesting thing about these startups is that they give you a lot of nodes, and essentially you're just trying to be very efficient because you get a percentage of the money. Oh, what's this? But I think we're probably gonna want a balancer to start. Let's have 2 decision trees. Okay, and we're gonna want blue to go up here and red to go down here. So this will send red and green. This needs to be 100% accurate. Ooh, oh, that's tough. That is tough. Okay, so red and green are going to come this way. We're going to send red here and green here. Going to need a trash can. Where's my trash can? Am I not allowed to have a trash can? Oh, that's a pain in the butt. I haven't really used the random forests. So I'm not really sure how those work. What do I want to do here? I want green squares to go here. And I want triangles. Alright, well, let's just see what happens. Let's just see how accurate we're being. All right, well, we're doing great on this blue category. And we're doing great on our green squares. But we're backing up. Let's stop this. I think we're gonna need more. Let's take a look. Let's try this again. So we definitely want to do a balancer. And I think we're probably going to want to split this again. Okay, and then what? Sift takes a long time. Decision trees don't take as much time. So I think we probably want to split these into colors. All right, so I want to isolate this by color. Okay, let's put this to blue and red. And then blue and green. Oh, this is a hard one. Right, we know we want green triangles. Oh, this is getting expensive. This is getting expensive. 10 cat euros a second. And we're not even anywhere close to done yet. I probably need to stop focusing on like worrying about the balancing first and start thinking about like what is the logic that gets us here. So we want red and blue, and then red and green will come here. Red and blue, then red and green will come, and if there's a triangle, then we're going to send it down here. Otherwise, we send it here. Okay, that'll work. Shisumo asks, how do you distinguish between outputs 1 and 4? Green squares can go in either, right? 1 and 4. Yes, that's accurate. Yeah, so what I've got here is, so the decision tree will send it to either one of these, red, blue, green, or any. And then if it doesn't match, it'll pick a random one. So if I have red going here, this will send red and green. Red and green objects here. And then this will send the triangles, red and green triangles down here. Otherwise, it's going to send them here and then split red and green. Blue, this is going to send, this will actually send blue and green. So I want green to actually go back here, I think. And then we want blue to go here. Then green squares. So we want green and red. So this will send green. Okay, so this is going to send green and blue. This is so complicated. Really, I don't know that I need this. I don't know that I need this balancer. It's gonna get backed up though, that's the only problem. Alright, so this is choosing red and green. So this will send... What if I make this any and this green? Oh, I can zoom that out. Oh, that's good to know. Green squares. So we're gonna have green, circles and triangles. Okay, we want circles there and triangles there. Let's see how this goes. Oh, that's backing up. I mean, it's accurate, so like... Oh, hold on. Alright, so if it's any other color that's not green, then we need it to go here. Whee! Okay. So I think what we actually want to do is make a couple copies of these and add in some balancers. Okay. I should have been paying attention during the tutorial. Let's see if there was a way to... Uh-oh. Shit. Oh, nope, it's fine. It's fine, everyone.
Stop panicking.
Yeah, everyone, stop panicking. Alright, so I will need a decision tree that is any and green. an isolation forest, which is green square. And a sift that is circle or else. Right, so this goes here. This goes here. This goes here. This goes here. And this goes here. Okay. All right, let's see how that goes. Whee! It's gonna get backed up on that that decision tree up there. Oh. And I'm just gonna send this up here for now. But really, I might want to send these two to their own. Whee! Wow. I mean, I know it's an abstraction, but it really makes you appreciate the problem of like large scale computing. Okay, so we've got two of these working in parallel. And we're gonna want to add at least one more of these. And do I want the sift there? Where do I need my balancers? I mean, would it help if you sorted out all of the blues earlier in the sequence? That is an interesting question. In essence, that's what this is doing. So I think that's a really good point. Maybe why don't I add a couple, at least one more of those. So this will go to here. And let's send these to the balancer instead of directly into that. And let's just try adding another red-blue decision tree. Okay. So we'll add a green-blue decision tree, a sift, triangle or else, and then a red-green decision tree. Okay, so bottom node goes here, top node goes to sift, top of sift goes down here, otherwise we go to red green. Then green node goes to sift, blue node goes here. All right. Okay. That's better. It's not perfect, but it's better. I think I think really what I need to be doing um is probably be adding balancers that go like having more of the sift nodes. Yeah. Because I think it's really like it gets stuck. Like it gets processed. Those sifts take a long time. So I think if maybe I can add balancers going in just to the sift nodes. Yeah, because I've got two things going into the sift nodes. Well, I just add another sift node. And then triangle goes to triangle, else goes here. And then triangle goes to triangle, and then else goes here. All right, let's try that. Whee! Okay, that's a little better. Yeah, those sift nodes are really slowing it down. How much is it to add a balancer? Oh. Ooh. Alright, I'm gonna hit save. Let's release this. And let's just see... Let's see how we do. Oh boy. Oh boy. Oh crap. Still losing money. And our users are unhappy. Oh boy. Oh, that's not great. That is not great. People are unhappy. Is it just the speed? See, spying on citizens is easy. Optimizing servers is hard. That's what I'm learning from this game. let's do what Chisuma was saying, and let's just have like a bunch of nodes where all we're gonna do is no, it's got to be simpler than that, right? Let's just split out those blue ones first. Red and green, and then red and blue, and green and blue. And let's just see, I know this is going to be wrong, but it sure is cheap. Look how cheap that is. All right, that seems reasonable. And let's do 2 of these. Let's add a balancer in here. Okay. All right, so we want reds there, we want greens here, we want blues here. Blue here, red here, blue here, blue here, green here. Okay. Now the greens, we want a triangle to go here. Otherwise, we send it up here. I know these balancers are expensive, but if they're green, I'm gonna do this because we need, we're gonna need some squares here. We want squares to go here. If they're not squares, they're going up here. Okay, so all the blues are handled. Then we're gonna do a sift, and if it's a green triangle, then it's gonna go down here. Otherwise it goes here. And then we're gonna do the same for red. If it's a red triangle, it's gonna go down here. Otherwise it's going here. Whee! It's still pretty slow. All right, but let's, oh boy. It's slow, but it's half the cost. So let's try that. Okay, all right, we're making some money now. A very little amount of money. Oh boy. And we went bankrupt. Shit. Well, we ruined Amazon, so I guess maybe we're not all bad. Shit. Alright. Well, we fucked up 2 startups, so I guess we're a real programmer now. Accuracy. Need harder machine learning job? Level up, maybe? Hi, friends, it's me again at Heller at Iser. Thanks for those jobs. I can now afford a meal almost daily, but I need a kick-butt video card to proceed with my task. Ergo, I need more monies. Am I ready for a more hardcore job, maybe? Little colders grow up so fast. No problemo, my Deuterino. I'll send you some more contracts your way, with bigger data too. Beware, in these tasks you'll be allowed to make some mistakes, but they're way more tricky to crack. How so? This is real-life data science for you. Corrupted data, incorrect data, useless data. When it comes to big numbers, that's not about being 100% correct. It's about getting the job done, sonny. Whee! Okay. Industrial. Ooh, okay. So we're getting to ones that I haven't done yet. Industrial espionage. Greetings. We hope that this message will remain confidential. We are Sniffer.all, an analytics agency. Our services include parsing data from huge companies. The issue lies in their protection systems. We have a very small amount of time to download all the data before we get tracked. We need an algorithm that will download the data. We need fast and secure. The payment will be sent to you after a first successful parsing completed with your program. Okay, let's see. So we want red or... Let's do blue. Blue or green. And this will send green and red this way. And then that'll send red and blue. Whee! Huh. Oh, that's tricky. That's tricky. Because we can't just split it in half. We need all 10 blues and 4 of the reds to go to the bottom one. And the rest to the top. What if we make this any? Nope. Nope, that's not gonna work. It's not gonna work. Let's make that any. And then we'll do green. Blue. Let's try that. Whee! Huh. This is a tricky one. It's not going to be accurate, though. Shit. Well. Alright, so we want all the blues to go here. And we want green squares to go here. Yep. Let's try that. Wow, that didn't work. All right, let's see. Does that send? All right, let's see if that just sends all the blues. Okay, that sends some blues too. Make that green. Damn it. Well, any ideas, anyone out there? I think I'm getting kind of tired. Random forest compares the color and shape of an element with each of the sockets and selects the one with the least amount of errors. Okay, so we want the greens to go here and the blues to go here. Just see what happens when the red goes up here. Because they're all squares. It takes a long time though. Maybe we do 2 random forests. And send this one here. Let's see what happens with that. See how that goes. Send our reds here. Yep. Nope. All right. All right, so we should be able to do this with just 2 nodes. red, blue, green. Blues have to go here, reds have to go here. And then maybe we just split up the reds. Takes forever though. This is a tough one. I thought I heard something fluttering. Maybe it was something in the ceiling. Were you watching the stream?
Yes.
Did you see anything?
Nope.
Well, that's disconcerting. Well, I'm gonna exit this challenge. Let's try this other one, and then I think I'm probably gonna call it a night. Client solvency assessment. Good afternoon. We represent the Money Bag Bank. We want you to create a system for sorting candidates applying for loans. We believe that cold soulless mind of a machine will help us save more money than our regular empathy corrupted human clerks. We'd very much appreciate it if you'd complete the task before the holidays. Proceed. Semi-supervised learning. Semi-supervised learning is used on partially unlabeled data with unknown answers. Typically, a machine learning model predicts answers for unlabeled data and uses this for prediction to improve. This method can improve quality of the model even when the data is not completely reliable. In real life, adding 5 to 10% of unlabeled data leads to minor quality improvement, and adding more data of this type spoils the model. Okay, so we want... But where do we want the blue to go? Alright, well... Okay. Whee! Huh. Okay, well that worked. Oh, good. Can I get hardware or nodes? Get another plant. Whee! Anyway. Alright. Raging birds. You know what? I'm just gonna end this on a win. It's been a long day. It's been a long day. Thank you for joining me. And, Ghost, are you planning to stream tomorrow?
Thursday maybe?
Yeah, Thursday.
Yes, Thursday.
Alright. Witchy Life Story?
Yes.
Okay. Well, thank you for hanging out. Come back on Thursday to watch Ghost play some Witchy Life Story. And we'll see you then. Okay. Thank you so much. Bye.